All right, in this problem, we have 1.01 times 10 to the 23rd atoms of oxygen in the water sample. That's a very important thing to figure out. It's not oxygen gas, oxygen in the water sample. How many grams of hydrogen gas are produced when the water sample is decomposed? Okay, so we know we have waters being decomposed. When it's decomposed, it splits apart to hydrogen gas and oxygen gas. 4 hydrogens, 2 oxygens, 2 oxygens. Hydrogen, oxygen, Frankelhoff are always diatomic. They want their twin with them when they're by themselves. When you look on your little mole island, atoms of oxygen is down here in particle island. But oxygen is a diatomic molecule, which means Avogadro's is going to give you molecules. So we have to go from atoms to molecules while we're still on that same island, atoms to molecules, and then we could use Avogadro's to get from molecules to moles. And what are we trying to find? So we have to go from moles of island A all the way across the USS mole ratio to get to mole island B. So we're on a completely separate archipelago here, and then we'll go to grams from that. Make sure you're using your chart every time. Atoms, we know 1.01 times 10 to the 23rd atoms of oxygen in H2O. It's over 1. So when we look at oxygen, there is 1 oxygen for every 1, 2, 3 total molecule, or 3 total atoms, okay, or 1 molecule. So in 1 molecule of H2O, remember it's the Mickey Mouse molecule, okay, there's 1 oxygen atom in the whole molecule, okay, and 1 molecule of water. Now we have to go from molecules to moles, which we use Avogadro's. There's 6.02 times 10 to the 23rd molecules of H2O and 1 mole of H2O. And now we have to go from mole A to mole B. That's our USS mole ratio. We have to use the information up here. 2 moles of H2O. Okay, so we have 2 moles of hot water for every 2 moles of H2O. And then at each mole of water, we have the molar mass, 18.02 grams per mole. So if we use our calculator, 1.01 second E, oh, it didn't do the 1.01, 1.01 second E, because that's that double E, 23, and then I like to hit enter and make sure, okay, yep, I did plug it in correctly, okay, times 1 molecule over 1, times 1, okay, so divided by 6.02 e to the 23rd, enter, times 2 over 2, those cancel, so times 18.02, and we have 3 sig figs, so 3.02 grams of H2.